Hi everyone, welcome to this video on area of sectors. Let's start out with just looking at what a sector is. A sector is simply like a piece of pizza. It is this sort of pizza-sized shape, but it could be the other side. Like the other side could also be a sector. So the angle that is inside this piece of pizza or this sector could be any size. So what I'm saying is that this part is also a sector because you have this angle and it could be that this side is the sector. We're typically going to use the smaller side, but just know that both of those pieces are called sectors. So today we're going to talk about, well, how do you find the area of something like that? Let's think back. This is going to be very related to how we found arc length. So think back to what arc length was. The arc length of a circle is a fraction of the circle's what? It was a fraction of the circle's circumference. And the fraction that you would find is the something divided by something. And it was the arc measure divided by 360. So if you were looking to try to find the arc length of this arc right here, you would want to know, well, what arc measure am I dealing with for this central angle, which is making this arc measure? And this arc length would be whatever that degree was. So say it was a 60-degree angle, you would do 60 divided by 360, which is 1/6 of your circle. So this arc length would be 1/6 of the circle. So likewise, a sector of the circle is not a fraction of the circle's circumference, but it's a fraction of the circle's area. And the fraction is still going to be the same. The fraction of that sector is going to be the arc measure divided by 360. Let's look at a really simple example here. Let's say you have a pizza with a radius of 9 inches. Let's just make a quick sketch over here. So you've got a piece of pizza, or a whole pizza, and the radius of your pizza is 9 inches, and the central angle is 40 degrees. So we're looking at a piece of pizza like this with a 40-degree angle. So we're going to see if we can think about how are we going to find the area of this sector. Okay, first question, step 1. What is the area of the whole pizza in terms of pi? So if it has a 9-inch radius, the area, of course, is pi r squared. So you would take that 9 and square it, so you'd get 81. So the whole pizza is 81 pi. That's the whole pizza. Well, what fraction of the pizza is that pizza slice? Well, because it has a 40-degree central angle or a 40-degree arc right here, we think about, well, what's 40 out of the whole circle, which is 360? We can reduce that. We can reduce 4 and 36, so we get 1/9. So this piece of pizza is 1/9 of my whole circle, of whatever that is. So if we know that the whole pizza had an area of 81 pi, and this one piece of pizza is 1/9 of the pizza, then the area of the pizza slice is 1/9 of my whole area, which was 81 pi. And so I would get 9 pi. So one piece of pizza would have an area of 9 pi. Okay, now that we've talked through all of that, can we write a formula for the area of a sector? Let's think about what we did. We started by finding this fraction. This fraction right here was on the top. What was that 40? That's the arc measure. So we're going to take the arc measure, which I'm going to write as AM, and we always divide that by 360. That's going to give us our fraction. And then instead of multiplying it by circumference like we did for arc length, we're going to multiply that by this part, which is the area of a circle. So it's arc measure over 360 times the area, which is pi r squared. And that is going to give us the sector area. So if you understand arc length, this is very, very similar to that. This is just arc measure over 360 times area, or pi r squared, instead of arc measure over 360 times 2 pi r, which was circumference. So this is very connected to finding the arc length, area of a sector. Okay, so let's practice a few. As always, you are welcome to play the video along with me and write down the notes as you go, or you can try these on your own and just check back in to see how you did with these questions. The first two are to find the sectors. So we're going to take our formula, which is arc measure over 360, and we're going to multiply that by the area of the circle, which is pi r squared. So in this problem, we're given both the radius and the arc measure. So we have 60 over 360. We're multiplying that by pi r squared, and our radius is 19. So when I square that, I get 361. When I reduce my fractions, 60 over 360, I can reduce the zeros and then divide, and I get 1/6. So we need to know what's 1/6 of pi times 361. Well, 6 does not go into 361, and we can't reduce this in any way. So our final answer is 361 pi over 6. That's as reduced as it can go, and this is going to be in meters squared. Okay, the second one, again, we have arc measure over 360 times pi r squared. The arc measure here, this is sort of the larger side. We have the major angle on this side with the major arc. And so we're looking at 225 over 360 times pi, and 16 squared is 256. And surely we can reduce 225 over 360. Let's see, what can we divide by? Well, I know I can divide by 5, and 225 divided by 5 is 45, and 360 divided by 5 is 72. Well, that makes it a little bit easier. Now I can divide by 9. 9 goes into here 5 times, and 9 goes into there 8 times. So my fraction is 5/8. So now I've got 5 times pi times 256 over 8. And I could multiply the 5 and the 256 together, but I think it's going to be easier to divide 256 by 8. 8 goes into here 1 time, and 8 is going to go into there 32 times. So my final answer is 5 times 32, which is 160 pi. And this will be in yards squared. So the area of this sector here is 160 pi yards squared. All right, so here we have one where we're going to work backwards. We know the shaded area is 12 pi, and we are going to find the radius. So since this is a sector, let's go ahead and do our sector formula to help us remember that. We have arc measure over 360, that's our fraction, multiplied by pi r squared, which is the area of our circle, and that's going to give us the area of a sector. Okay, so the arc measure is 120, so 120 over 360, that's the fraction, multiplied by, we don't know the radius, so we're just going to leave it as pi r squared, and that's going to equal 12 pi. Let's start by reducing this, so 120 over 360, that's just 1/3. Right away I noticed I can get rid of these 2 pi's, so I've got 1/3 r squared, or just r squared over 3, is going to equal 12. Let's multiply by 3 on both sides, so we get r squared equals 36. Take the square root of both sides, so r is radical 36, or r is 6. My radius is 6 centimeters. These questions, when you work backwards or when you're solving for something, sometimes they seem a little bit harder, and so it might be a good idea to just do a quick check by going forward. Like, what if your radius was 6? What would your area be? And go through it that way, and that's just a good way to double check yourself. Okay, this last problem is very much like number 2, so I strongly encourage you to pause the video and try it by yourself, and then come back and check your work. But if you're feeling really confused, of course you can just follow along with me if that's what you'd like to do. Okay, so the shaded area of this sector is 20 pi, and we need to find the radius. So let's start with our formula. Arc measure over 360 times pi r squared, the area of the circle, will equal the area of our sector. All right, let's fill in what we know. So the arc measure we know is 144 degrees, and we're trying to find the radius. We don't know that. And we know that the shaded area is 20 pi. All right, let's reduce our fraction, 144 over 360. I know that 12 can go into 144 12 times, and 12 can go into 360 30 times. And then I can reduce again by 6. Okay, so we have 2/5 pi r squared equals 20 pi. I can cancel out the pi on each side, and I'm going to rewrite what I have over here. So we've got 2/5 r squared is going to equal 20. Let's get r squared alone by multiplying by 5/2 on both sides. So we get r squared equals 100 over 2, which is just 50. So r is going to be the square root of 50, or 5 radical 2.